This is section 5.3, which has to do with polynomials. This is an example of polynomial. This particular polynomial has 3 terms. We call that a trinomial. This is the first term, second term, and third term. Whatever is the highest power of the variable here that's being used is x, the highest power, this is called the degree of the polynomial. The highest power. So this is a third degree polynomial. Okay, if you have only 2 terms, this would be called a binomial. And you can probably predict what we call something that just has 1 term. We would call that a monomial. This is a variable term because it has a variable, so its value can change. We can also have something like this. This is also a monomial. And it is a constant. It is always 5. It's not variable. It can't change like the one above. Okay? So we have the degree of the term. The degree of this term is 3. The degree of this term is x to the first. The degree of this term, well, there aren't any x's there. So we think of this again as having x to an invisible 0 power, because anything to the 0 is 1. So a constant has degree 0, x to the 0 power. But then again, each term can have a degree, but the polynomial degree is what we're usually most concerned about, and this is a polynomial of degree 3. We're working toward learning how to factor these and work with these polynomials, so we have to get this basic vocabulary down first. If we write this polynomial equal to f of x, we're using our function notation that we've talked about earlier, which is another way of saying y, and then we can plug in values and do a graph for this, and we'll see some of that coming up. Alright, so first of all I want to test you on some of this vocabulary that I just introduced or reminded you of. Most of you have seen this before. 1a, 3x. First of all, what is the degree of this? Well, the degree means the power of x there. This is a degree 1. We're supposed to state how many terms it has. It's a monomial because it only has 1 term. And indicate whether it is a monomial. Oh, we said that already. Okay, so it has 1 term, which makes it a monomial. They seem to want you to tell both of those, which seems a little silly to me, so I don't think I'll do it again. 9x squared is the next one. This again, the degree of this means the highest power of x. The degree here would be 2. And this has only 1 term, so we say it's 1 term or a monomial. And then we can look at the next example, which is negative 2x cubed plus 5. This has degree, look at the power of x. The degree of this polynomial is 3, right? The degree is 3. And this has 2 terms, so we call it a binomial. All of these make up a family called polynomials. Poly means many, so even as many as 1, this is a monomial polynomial, right? This is a binomial polynomial, but they're all polynomials. We follow the characteristics of that. And this is a very strange one. I don't even think it should be included, so I'm going to just wipe it out. That should have been letter D. Okay, moving on to number 3. We're supposed to define a polynomial function. Let's move on to 3 and work some more examples here. Number 3, part A. It asks you to simplify by combining like terms. So, what we know here is that the terms are both x's. Those are alike. So it's like we had 2 x's, right? And then we had 3 more x's. And we're adding all that together, which would give us a grand total of You just have to take the coefficients. These are called the coefficients. That's how you spell it. And we get 5x. So 2 of these plus 5 of these gives us 2 of these plus 3 of these gives us 5x. Part B. We have a new variable here, y. We have 10y's minus 8y's. Okay? And so you just think, how many does that give you? If you had 10 and you removed 8, you would be left with 2y. Alright. Now, we haven't really talked about this, but these have to be what we call like terms. If we want to combine things, they must be like terms. Like terms means that they have exactly the same variable and power. These are like terms because they're both x raised to the first power. These are like terms because they're both y's raised to the first power. When you have like terms, they can be added together. So in this next example, we do not have all like terms, right? We have this xy, and this is a like term to that because they have the same variable and powers. Okay? So it's like we have an invisible one of these minus 2. So just take your calculator. 1 minus 2 gives us negative 1xy. And then the 3x. These are not like terms. Although they both have the x, they don't both have the y. So only like terms can be added. And now moving on to D. First, we go through and we look for the like terms, and we will begin with the highest power. Why not? We'll do the x squareds first. I have negative 6 of these minus 3 more, which gives me negative 9x squareds. And then I have a negative x plus a 2x, which gives me a 1x. Okay, let's go ahead and try part E. I thought I would look and see how the answer key is doing. You know, I periodically check it. That was D. It's looking good. They arranged these in a different order, but it's the same thing. And let's go ahead to part E. We have a negative 9y plus an 8y plus a 9y to the 5th. Okay, see if you can identify the like terms there. Remember, to be alike, they have to not only have the exact same variable, but the powers, the corresponding powers, have to be the same. So yes, in this problem we have the first two terms are like terms. Negative 9 plus 8 gives me negative 1y. You can put the 1 if you want, it's optional. And then we have the 9y to the 5th. That's the second term. And this result is a binomial. Now we move to F. It doesn't look too nice. These are the lecture notes that are posted on Blackboard. Okay. I'm going to start with the ugly xy squareds. Do I have any others that are exactly the same like terms? Xy squareds, yes. Now, how many of these xy squareds do we have? Let's see. We have 8 minus the 2 gives us 6 of these. Alright, now I'm going to look at the next variable, the x's. I have a 3x and a minus x, which gives me a 2x. And then the lonely 3/5 that isn't like anything, right? Which I'm thankful for, otherwise we would have to potentially add the fractions, right? Okay, that concludes number 3. We've been adding things horizontally. We've worked across in a horizontal direction. Now we're going to do a couple of problems in a minute, in number 5 actually, where we're going to do vertically. So first let's combine some terms using addition with, again, the horizontal method. The first problem says to take negative 3y squared minus 2y plus 5 and to add to that, so we have a trinomial, and we're going to add to that a binomial. And again, to add these, the parentheses aren't really doing anything. If you wanted to, I'll do this on the first one, never again, we could drop them off. Okay, and then what we want to do, since it's adding, the plus doesn't just distributes through and doesn't change anything. We find the like terms. Let's double check that I've copied this correctly, and yes, I have. This is the only term that has a y cubed, so I have a negative 3y cubed. Okay, and then I'll switch colors, and I'm going to find everything that's just a y to the first, right? Y to the first, and I have negative 2y to the first plus a 2y to the first. That gives me 0 y to the first, so I don't even need to write that down. And then finally I go to the constants. I have a positive 5 and a positive 7, which make 12. Form number 4, part A. Okay, let's move this up and do the next one for B. Remember that you have the ability to pause this lecture at any point and stop and go back and replay. Another good thing to do is to write down the problem and stop the lecture and then try to work it yourself and then turn it back on and see if you're able to get the correct answer. So this is a nice feature of the recorded lecture. Okay. Now here again we're adding, so that isn't going to change anything. We're really just taking this first one just the way it is, plus that, plus this. So I distribute the plus, it just doesn't do anything. Now I want to look for the x squareds. I have positive 2 minus 6 gives me negative 4x squareds. And then how many x's do we have? We have negative 3 minus 7, which gives us negative 10 of the x on 4b. Looks good. Let's move on to 4c. On 4c, they're asking us to take, oh, now they've written it vertically. This is interesting. 5x squared plus 3x minus 2. And add to that, and they've placed a parentheses there, 7x squared minus 5x minus 3. Adding is so much easier. So in adding, this plus doesn't do anything. We just add straight down. So we're going to add the terms. It doesn't matter which side you start on. I'm starting with the right side. You know I'm semi-dyslexic here. Negative 5 plus a negative 3 gives me negative 5. Negative 2 plus a negative 3 gives me negative 5. All right, now we add down this. How many x's, right? So you can see how these have sort of lined up. Now we do the x's here in the middle. We have positive 3x and negative 5x, which gives us negative 2x. And now we combine the x squareds, these like terms. We have 5 of these plus 7 of these, giving us a total of 12 of the x squared. So the answer is 12x squared minus 2x minus 5 on 4c. And this is done vertically. Okay. And it's the same. If you like it the other way, write it the other way. I don't care. Alright, subtraction is a little trickier, and I'm not exactly sure why they've written the first example vertically, because usually you don't do that. This is 5a, negative 6x squared minus 3x plus 9 minus, and then they've put a parentheses, 7x plus 10. Now, the problem with this problem is that we're supposed to subtract all of that, okay? So I think of this as 6x squared minus nothing, right? And you might even want to go through and say, this is really going to be like a negative because I'm going to subtract it, and this is going to be like a negative 10 because I'm subtracting it. So I have a negative 6x squared, then it's negative 3x minus a, see there's the minus the 7x, which gives us negative 10x's, and then 9 minus 10, which I wrote over here, 9 minus 10 is negative 1. So you don't really need both of these, so you could either leave the negative out front, or you could say I will apply that negative to the two terms and then simply add, right? Okay, so this is what you want as your answer here to the subtraction. And that was A. Let's look at B. B says to take 4x squared minus 3x minus 15, and from that to subtract this entire polynomial, 5x squared minus 3x minus 22. Alright, so I'm going to do this as a method of changing it to addition. I'm going to apply the negative all the way through the parentheses. Using the distributive property, this is like a -1 multiplied through. Negative times this will make that negative. And I'll circle this to let myself know that I've changed it, okay? So I'm applying this through. Negative times negative makes this a positive. And negative times this negative multiplied by the negative makes this a positive. Once I've distributed the negative through, I can simply add, okay, because I put the negative through. So I'm going to have a negative x squared, that's a positive, and a negative 3 make a 0. 22 minus 15 is 7. Looks good. And if you've done this a different way and would prefer your way, feel free. As long as you're getting the correct answer, it can show us some work, okay? 5c, 2x minus 2 minus negative x minus 2. Now you may want to make a mark beside this. This is the way I will print it out on your quiz, your worksheet, your test, in this horizontal form. So what I would expect you to do here is to begin by distributing the negative all the way through. The most common mistake is only to do it to the first term and forget that one. So don't do that. So we're going to have 2x minus 2. Negative distributed times the negative makes a positive x. Negative multiplied by the negative 2 makes a positive 2. Now that I've put that all the way through, I can simply combine my like terms. Here are the x's, giving us a total of 3x. We have a minus 2 and a plus 2, which cancel out and make 0. So this would be simplified. After we subtract, that would be the answer. Then the last question here, if you ask me, is a little out of place in this section. It asks us to match each equation with this graph. Okay, and let's see if I can. It's always dangerous to try to adjust this camera. Well, it didn't work very well. These are teaching notes. I don't think I read them very often, but you can read them. They're on your paper too. This is not a line. This is the only one that's a line. So when I go trying to match, I'm going to pick out the equation over here that I know is a line. And we've done lines, and we know that when you have a line, x is to the first and y is to the first. So this is the only linear equation. So C must match with graph number 2. Now when I try to decide between these, you might already know that something with this shape is called a parabola, and it's going to have an x squared. So I happen to already know that, right? B matches with 1. But if you don't know, give yourself a test point. In this first graph, when x is 0, what is y? Y is 2. I'm just looking at the graph, and I say it goes through the point 0, 2. So I'm going to check this into here and see if it works. If x is 0, put a 0 in there, then y would be negative 1 in this equation. So that does not work for this picture. In this picture, 0, 2 is on this graph. So I try a 0 here for x. 0 squared is 0, minus 2 is negative 2. I can see that this point, in fact, does solve or satisfy this equation. And so that's 1. And that means this must be, and that's the basic shape of a cubic, this must be matched up with that one. So there we go. We've done the matching. Probably you can't expect to see one of those quite yet till we've covered a little bit more on graphing. Okay? That concludes section 5.3. Please remember to do your homework now.